Welcome to another week of the online 1212 lab here in North Georgia. My name is Dr. Meyer. This week we're going to be taking a look at our molar mass lab. And really what we're going to be doing is that we're going to be really kind of examining this idea of freezing point depression. We're going to be doing that for naphthalene, which thankfully you can actually count yourselves a little bit lucky that maybe you're not doing this lab in person, because naphthalene is what makes up mothballs. So you actually get to skip a full afternoon of kind of smelling like mothballs after doing this lab. But what we're going to be taking a look at is what I have here is I have naphthalene, just pure naphthalene, that I've masked out and put in our test tube. And we have three main parts to this experiment. This first part, what I'm going to do is I'm going to take this naphthalene, I'm going to go ahead and actually lower it into this hot water bath that I have here. And I'm going to let this naphthalene melt until all of it's just a liquid. This hot water bath at a temperature, it's about a little over 90 degrees. Naphthalene melts around 80-ish or so degrees if it's pure. So what I'm going to let happen here is I'm going to let the naphthalene go ahead and fully melt. And then what we're going to do is I'm going to actually pull it out of the hot water bath, and I have a thermocouple here that'll actually be recording measurements of the temperature change over time. And what we're going to look for is on this lab quest that I'm going to use to kind of actually make these measurements, we should actually see kind of a decrease in temperature, but then eventually we're going to hit a point where the temperature kind of either levels out or plateaus or maybe even spikes back up a little bit before it starts to decrease again. And that little plateau, and hopefully if we're lucky to see a little spike as well, that's what really correlates to our freezing point. So we're going to have kind of two temperatures that we'll really keep an eye out for. I'm going to show for the first trial, I'm going to record everything, and you can kind of watch everything cool down. I'll show kind of a zoomed in look at it as it's happening and point out like when crystals are forming and things like that. And I'll also have like the actual data that you can look at as an Excel file for this trial and the others as well. And what we're going to do is we're just going to see like where does everything freeze. Visually, we'll probably start to see some crystals form before freezing happens. But when we see that temperature plateau or that spike, that's when we hopefully should notice our solution almost entirely going solid. Or at least the solution, at least particularly around the thermocouple that we'll have down in our sample, should be going solid at that particular temperature. That'll be our freezing point. That's really the only goal of this first part, is figuring out what is that freezing point of pure naphthalene for our setup and things that we're using. Then the next two parts of our experiment, what we're going to take a look at, the second part, we're going to add a little bit of something called biphenyl. And it's basically just another organic compound that will dissolve easily with the naphthalene. And we're going to look at how does adding that bit of biphenyl affect naphthalene's freezing point through this idea called, or basically through this phenomenon called freezing point depression. So we expect to see our freezing point decrease. We will see it decrease. And we'll look at how much it decreases for the amount of biphenyl we add. From that, we'll actually be able to do some calculations, or you guys will be doing calculations, to find the freezing point depression constant for naphthalene itself. And then use that constant in the third part of the experiment when we're going to add an unknown compound to our naphthalene test tube, and then we're going to see what's the new freezing point with that new unknown compound. And based on the mass of the unknown that we add, the mass of the naphthalene that we started with, we should be able to do some calculations using our freezing point depression constant that we find in the second part of the experiment to figure out what is the approximate molar mass of our unknown. That's kind of the end goal that we're going to be trying to work our way towards. But for the first part, it looks like we're getting pretty close to having all of our naphthalene melted. It's not quite all there yet. So I'm going to go ahead and kind of pause our video here now for a minute. And then when I'm going to kind of restart things, you're going to see all the naphthalene fully melted. And I kind of a zoomed in look basically of the melted naphthalene, so that we can then start watching it cool down and kind of see the general process of what we're looking for each of the parts of this experiment. All right, so at this point, all of our naphthalene is melted. So what I'm going to do is I'm going to go ahead and take our sample, and I'm going to raise it up out of our hot water bath. And on here, on our lab quest, I'm going to kind of show this real fast. You can see it telling us what our current temperature is. I'm going to change one quick thing here for our duration. I'm going to set it to make sure it records long enough for us to see everything we need to see. Hopefully it won't take a full 10 minutes to record everything, but we'll let that go. And what this lab quest is going to record is basically temperature versus time data. And I'm not going to show this the whole time, because really what I'd rather focus on is what we're looking at over here. Right? So we have all of our naphthalene is fully melted. Right? Everything is a liquid here. And what we're going to now basically do is just kind of watch for everything to solidify. And so I'm going to be waiting for looking and kind of in our solution, when do we first get crystals to form? Oh, I can keep this kind of prop for it. And not only when do we first get crystals to form, but also then if we're looking at our actual data down here, how does that compare to the freezing point temperatures that we're going to see? Because crystals are probably going to form before we actually are able to measure a freezing point. I'm just kind of adjusting some things so things will hopefully sit nice and stable. One last little stir here as things kind of get going and start getting ready to cool down enough to solidify. But really it's now just kind of a waiting game. So I'm just going to let this kind of run for a little bit. And we're actually going to see it kind of slowly cool down. I'm going to kind of zoom in so we can get a better view of things here. Maybe even raise this up just a touch higher so you can see it. Apologize for not being a camera expert here, but hopefully this will be a good enough view of things to kind of see what's happening and when. And I'll make note of the temperature of when we actually start to see some crystals actually form in our solution. If you actually look in our solution right now, do see some stuff starting to kind of form at the bottom, and you've actually already seen it probably, especially around the edges up here, where it's already started to solidify a little bit. And we can't quite see any, and really the temperature where crystals first start to form, you should see things get kind of sparkly, almost like little sparkles in the solution that should become visible. Not quite there yet, although our solution is looking like it's getting ready to freeze. It is very kind of slowly still cooling down. And I'll show you the plotted data here in a moment of what it looks like on our LabQuest. But looking at our solution, you see the top is almost starting to freeze. We still have some kind of chunks in the bottom. So I would say this is probably where our crystals have at least started to form. We're at a temperature of about 78.2 degrees Celsius. So I'm gonna go ahead and record that temperature. And now we're gonna wait and just kind of see how long it's gonna take for all of this to completely solidify. And we'll have our plot of data that'll actually show our temperature versus time that I'll also kind of show once things are done cooling. I'm gonna let this keep running for now and actually kind of just let you kind of see the process. The next couple trials, I'll probably skip this cooling process and really just show you the data so that you don't feel like you're just sitting here watching stuff the whole time on a video while we wait for things to kind of cool down and freeze. All right, and so now if we're looking at our sample, I go to move around our thermocouple, it's pretty much stuck in there because our whole solution has frozen through. So at this point, I'm gonna go ahead and stop collecting data. So we'll have a data set here that runs for about 400 seconds or so, so it didn't quite take a full 10 minutes. I know it's not the most exciting thing to sit and watch something freeze, but if I take a quick peek here at what our data is gonna look like, if I can show this in a good scale, there's our data of kind of our temperature, and what you see is kind of our constant decrease, and then all of a sudden it kind of plateaus. We actually even see a little bit of a spike, both kind of here and here. Not collecting enough data points, so I'm probably just gonna redo this whole thing. All right, so now you've seen kind of the general process, you saw our solution freeze and kind of where to cut things off. What I want to show you is all of the data from that first part of the lab, and I'll do this kind of for each of the runs. So over here, you're going to see all of our recorded data and kind of the measurements, like my test tube mass of the test tube plus the naphthalene, subtracting the two to get the mass of the naphthalene. That's a little bit bigger than the 5 grams they asked for. It's not that big a deal as long as they have the measurement. And then these two parts, this I get from visually watching the actual when did the first crystals form that I made note of. And then this part is actually then from the data that I have here. So again, getting the temperature where crystals first form, that's kind of your visual confirmation. The actual freezing point is what we're trying to extract from our recorded data on our lab quests. So how we figure out this last part, where that freezing point in the naphthalene is. If I'm looking at this plot of data, I'm seeing this is a constant kind of decrease all the way down. There's a couple little aberrations here, but it's still pretty steadily decreasing. And then all of a sudden I get a little tiny spike here, almost kind of more just a plateau, and then it's kind of slowly decreases before starting to steeply decrease later on. What I'm looking for here is like, where does the slope of everything really highly change, right? It's decreasing pretty rapidly, gets down to here, and then everything kind of flattens out and plateaus out a lot. And so the highest temperature where that kind of slight spike or plateau occurs is what we call our freezing point. And there is a little tiny spike in the data right about here. I'm getting a freezing point of about 79.1. Is kind of the exact point on that plot that I've kind of highlighted right there. And if I move where my little cursor's highlighted, so you can kind of see that little spot that I was looking at, there's this little tiny rise right in here that's happening. That I was trying to pick out the highest point in that little rise. That's where I got the 79.1 degrees for the freezing point. And that's how I'm looking at this data. Now, for your actual post-lab work, on D2L, you're going to see an Excel file that will have all of this data from this trial in it. And you'll see the same for trials 2 and 3 as well. So you have the Excel data that you can use to make plots that CSE Pub will ask for. But for the next two parts, I probably won't give you this freezing point. I'll just let you figure that part out on your own. But I will give you the temperature where the crystals first form. The temperature where crystals first form is usually close to the freezing point. Can be a little bit above or a little bit below, just depending on what your data looks like. But it's not usually the exact freezing point itself. So kind of keep that in mind. Just because I'm going to give you this number in the next two trials, because you kind of have to be there doing it visually to see it, don't assume that the freezing point is going to be that same number, because it usually is a little bit different. The freezing point comes really from what your data looks like and kind of interpreting the data that you have. All right, so the next little spot, I'm going to show you kind of how our next part's going to work, how we're going to get our biphenyl. We're going to add the biphenyl for the second part of the experiment. All right, so what I have here now, I'm going to move on to the second part of the experiment. What I've gone and done is I've massed out 1.207 grams of biphenyl. So this is our known compound that we're going to be adding to our naphthalene. And I'm just going to very carefully add this to our naphthalene that I've now remelted down in our test tube. Make sure I get it all in there. And I'm going to give this all a minute to kind of coalesce and melt down in there. But what we're going to do is once that's all kind of remelted down, notice this is the exact same setup I had in part 1, which means the test tube mass, the naphthalene mass, all of that is the exact same still. But once I have all of that remelted, then I'm going to go ahead and basically just do the same thing I did for the first trial, which is I'm going to lift it all out, and I'm just going to slowly let it cool down. I'll make note of when those first crystals form, as well as then when the solution is totally solid. And I'll show you all the data points again, kind of like I did for that first trial, and kind of just repeat that general process. So it looks like actually everything is already melted. So I'm going to go ahead and lift our test tube up out of the hot water. And again, I have everything kind of set up here ready to record. I'm going to get my lab quest ready. Tell it to record but store my previous data. For those of you that are going to have to use them maybe again in the future, if you tell it to store and record, it'll keep all of your data for all of your trials in one kind of file that you can look at later. I'm going to lift this up maybe just a touch higher so we can zoom in on this better. Apologize for not having an easy kind of expert camera set up here. So now if we take a look at our solution, we're just going to wait and see like when do we first get crystals to form, as well as then when is this thing going to be fully solidified. And notice it should take a little bit longer for this to happen this time. I'm going to just mix this just a little bit, make sure everything's good there. Mainly just because naphthalene itself freezes at, we saw 79.1 from our first trial. Now that we've added stuff to the naphthalene, our freezing point should be lower. So it's going to take a little bit longer to freeze, although it is cooling down still very quickly now that we've removed it from that hot water bath. In fact, we're already below where naphthalene would have frozen previously. And so if we take a look here at our solution, keep kind of an eye on it. We don't really have a whole lot going on in our solution just yet. So just kind of keep an eye to see when we actually get the first kind of inklings of anything actually happening in terms of solids forming, things like that. I'm actually not going to stir the solution anymore or kind of mess with it, because that can actually sometimes lead to some like weird blips that you'll see in the data as your thermometer is recording everything on your LabQuest. And so I'm just going to wait and see when we first get our first sign of crystals. Still don't really have much yet in the actual solution itself, and we're already down to about 72.5 degrees or so. So good bit lower than what we saw at the freezing point the first time, which is, like I said, what we hopefully wanted to see here. And so I'm going to give this a couple minutes, let you guys just kind of watch, and as I see the crystals form, I'll kind of highlight it and point it out, and then I'll let it go all the way through till solid like before. And for this part of the video, if you want to skip till the end where there's going to be data, that's fine. Don't feel like you have to sit and watch the whole thing just solidify. I know that can be a little bit boring, unfortunately. All right, well, I'm actually going to chime in already. It does look like we're starting to get our first crystal formation, particularly on the bottom of our solution. There's actually crystals already starting to form. It's not the easiest thing to quite pick up on the camera. You can actually probably start to see it, the kind of the fogginess maybe near the bottom start to increase. That is actually a little bit of crystallization happening there. And we are starting to see from, I'm looking at our plot that I'll show here in a moment, a little bit of a plateau here. So we're starting to get to what looks like our first crystals. Looks like the first crystals formed at about 69.4 degrees Celsius. From the thermometer that I'm looking at. Remember, 69.4 is not necessarily the freezing point. You're actually going to look at the data plot that I give everybody for this to kind of make that determination. But that's where we first started to see some of this crystallization happen. And if we're looking in here, it looks like we're starting to get a bunch of big crystals at the top and the bottom. The full solution hasn't quite solidified yet, although it is starting to get pretty close. So I'm going to let this go for probably just another minute or two here. And then we should be done with trial 2. All right, so it looks like this thing's pretty much frozen solid now all the way through. There's maybe just a tiny bit of liquid still left in it, but it's almost solid all the way through. So I'm going to cut off kind of this portion of the image here, and then what I'll do here in just a second is I'll show you guys kind of the plot again of the data on the LabQuest, along with all the measurements for this portion of the lab. All right, so I want to show the data here for the second part of our experiment. So I have all of our measurements. Notice the mass of the test tube plus the naphthalene and the naphthalene mass are the same for part 2 as part 1, because all I just did was add the biphenyl directly to that naphthalene we already had. And so that's the biphenyl there that you saw I added to get to that total mass. And then here is the crystals where they first started forming, about 69.4 degrees Celsius. And then here's the actual quick plot of the data. Again, I'm going to send you guys that you're going to have access to the Excel files on D2L, as well as for the CSC pub part, you'll see a link at least to this picture through the video that you can take a look at. But it looks like if we're looking here, our temperature is pretty constantly decreasing. And then all of a sudden, we don't see a spike back up, but we do see it pretty heavily plateau right in here. Right? So we're looking at a freezing point that's somewhere right in here about where you think it's starting to plateau the most. There's obviously going to be a little bit of level of interpretation here, so you're not expected to get this exactly down to 1 decimal place, the exact number we think, just within reason. And so somewhere kind of in this range temperature-wise for where that freezing point is going to be this time. Looks maybe in the ballpark of 70, probably a little less than 70 degrees Celsius. But that's something that I'll leave up to you guys to figure out from the data as you're going through and doing the calculations. We have one last part of the experiment, so that's what I'm going to show next is kind of the quick setup and the reset for part 3, and then we'll look at its data as well that we get from it. All right, so I'm ready to set up part 3 of this experiment. And what I'm going to do for this last part, I have a whole fresh new sample of naphthalene. So I have the naphthalene, and I've masked out a little bit also of my mass, I'm sorry, not mass, I've masked out my unknown, which in this case is actually going to be something called benzophenone that I've already pre-masked out that I'm going to be adding to my sample. And what I'm going to do is I'm going to take all of this again and melt it down in our hot water bath. So I'm going to take this down. Going to let this start melting. I've taken my thermocouple here, I still have it. I've gone ahead and cleaned it off so that we can use it for this last trial again. And I'm going to give this just a couple minutes for everything to melt. And then we'll go ahead and add our thermocouple, remove everything, kind of watch this one the same way we did the first 2 trials. All right, so it looks like everything is melted now. I'm going to go ahead and pop this up and again kind of zoom in our view as best I can. I'm doing this appropriately here. So we're again going to kind of zoom in here and kind of see how long it takes for crystals to start forming again for this last part. And again, we should expect this to work similarly to what our last time was. Since our second trial also had some contaminant effectively in our naphthalene that caused the freezing point to go down, we saw it go from about 79.1 down to kind of around probably a little bit below 70 last time. Probably expect something somewhat similar this time as well. Our unknown compound, if you're going to look it up, and you'll see I have it written down in a moment, is benzophenone. So you actually can look up what its molar mass is in advance to see how accurate your results are going to be once you get your actual freezing point and everything picked out from this trial and your freezing point depression constant kind of determined from your results in part 2 of the experiment. And so our goal here again, just going to wait for our solution to solidify. We'll make note of when crystals are forming. We'll keep an eye on that, and I'll kind of make a note of as I start to see that, kind of either at the top or the bottoms where we usually start to see them. Ideally, we'd like to see like little glints and almost of light being reflected by the crystals forming in the solution itself. Sometimes that's easier to see than others. In this camera view, it's not very easy to see, so it's easier for me to kind of point out the top and bottom crystals as they start to form when that happens. But I'll point that out, and like I said, I'm just going to let this kind of run. And then once we get done with this particular trial, again, I'll kind of go over the data like I had in the previous ones. So it does look like we are starting to get some crystal formation here. You can start to see like along the bottom, but even some strands going up and down in the solution. So definitely crystal formation here. Temperature was 69.0 degrees. Again, much lower than 79 or 78 where we saw the crystals form for the very first trial. It was pure naphthalene, so that's good. You can actually start to see the solution solidifying pretty quickly here now that it started to turn. And so I'll let this go for another minute or two here while it finishes kind of freezing all the way. And then, like I said, I'll kind of present all of the data and show all the data for everyone at that point. And it looks like our solution's frozen through pretty solid already. So I'm going to cut this portion of the video off here, and then I'll show kind of some video with all of our data displayed out like I have for the last couple trials here in just a moment. All right, so here's our data and kind of visual plot for the third part of our experiment, the last part. Again, see our mass of our test tube with naphthalene, test tube with the naphthalene and the unknown. So we have our mass of naphthalene and the unknown. But remember that unknown ends benzophenone, so that's what you can enter for your unknown ID on CSE Pub. And you can actually use that to help check how close your final molar mass is to what's expected for benzophenone when you get to the very end of the lab. Quick look here at our data. I didn't let this one go quite as long as the last couple trials, mainly because I thought it was pretty pronounced as far as where you could see the freezing point at. Right, we see a pretty steady decrease, then it levels out pretty hard. It doesn't spike back up, but that's a pretty significant plateau. Then it starts decreasing a little bit more after that. So right in here, I think very clearly is where we have our freezing point. And so you can, again, pick that out somewhere a little under 70 degrees. You can pick out what you think that exact freezing point is to use for your data. Here we made note, crystals formed at 69.0 degrees. It's probably not too far off from what the freezing point was this time. All right, so that should be all of the data that you need to do all of these calculations for this lab. The calculations do take a decent bit, particularly like parts 2 and 3 are related to each other. Right, part 2 you need to find that basically the freezing point depression constant for pure naphthalene, and use that freezing point depression constant in the third part of the experiment to help you find the molar mass of benzophenone, or at least the experimental molar mass of benzophenone that you can then compare to the real value. So that should be it for this week's lab. One last note as far as cleanup. Naphthalene, it's not something we can just kind of send down a sink. So one of the things that you're going to see me do, I don't know, you're not going to see me do it off camera, but cleanup-wise, naphthalene, basically when we're done with everything, we remelt everything one last time, and then while it's all still hot, quickly dump it into a waste container that's specifically for naphthalene. That way, it's a liquid, it's easy to kind of get rid of and remove from our glass test tubes, and then it'll solidify in our waste container, but at least then it's contained in our waste container for us to get rid of later. So that's kind of the general waste disposal. Nothing from this experiment goes down the sink. Naphthalene, benzophenone, biphenyl, all three of those compounds that we use are organic-based compounds that are pretty bad for the environment, so we can't just rinse stuff down the sink. All of it does get specifically collected for our waste. But that's all I have for this week, and we will see everyone next time.